Hi everybody, welcome back to the Feynman technique. Today we're going to be solving this integral. This is, I'm calling it the double cosine integral because it's got two cosines in it. Alright, so we're going to be treating this as a function of a. And we are going to use this tool right here. We're going to start by knowing that this integral evaluates to pi over 2. And we've derived that in a previous video on this channel many times. Okay, so we're going to be using that. So our first step, again, is to treat our integral as a function of a, where b is just an arbitrary constant. Okay, now we're going to take the derivative of our function of a there, using the Leibniz rule for differentiation under the integral sign, which says we can pass the derivative inside as a partial, and then evaluate the partial, then evaluate the resulting integral. All right, so if we take the partial with respect to a of the integrand, you'll notice that the only part that relies on a is this. So that's the only thing we need to take the derivative of, and its result with respect to a is this, negative x sine ax. So we put that in there, and now this is our I prime of a, and you'll notice these x's will cancel. So now we just have I prime of a is equal to this. And now we can make the we'll clean up here. Now we can make the substitution u is equal to ax, meaning dx is 1 over a du, plugging that back in, and we are just left with this, which we know from our toolkit is simply pi over 2. So we have I prime of a equal negative pi over 2 now. So we integrate back to get I of a. Integrating that gives us negative pi over 2a plus c. Now we need to solve for c. You'll notice if we set a equal to b in our original I of a, it should have been over here in the toolkit, but let's go back to see what our original I of a was. So I can show you that plugging in a is equal to b is going to give us 0. So let's go back to where we were. All right. So if we set a equal to b in our original integral, we get 0. That means I of b equals 0. Well, that means 0 is equal to this, which means c is equal to pi over 2b. And we plug that in and do some algebra, and we have our final answer for our integral, and that is pi over 2 times quantity b minus a. All right, guys, hope you enjoyed that. We'll see you next time.